All right, so these are all the words you need to know. That's literally it for all of GCSE polymers. Okay. And we'll start off with the keyword polymer. What does it mean? All right. And a polymer means a string, a big string of molecules all joined together. All right. And if I pick a hexagon, I've picked it for a reason, but I'm not going to tell you the reason. Not yet. So if we got lots of hexagons joined together, right, this is a polymer. Poly means many. There's a really cool word that I like, polyglot, meaning many languages, somebody who speaks many languages. So poly means many. Polymer, many mers, right? Many mers. So we string lots of these units together, these little units. Doesn't matter what a unit is, we'll look into them in a while. So this is a polymer, and it'll keep going on forever and ever and ever. Well, not really. About 10,000 that way, 10,000. It can go 100,000. They can be huge. So it'll keep going this way, and it'll keep going this way. And this is a polymer. If you look at one of these, so almost draw a rectangle, hexagon there. This is one of them, and this is called a monomer. Monomer, one of them. All right. So a single one of these shapes joined together. So a single one of these shapes not joined together is a monomer. Have a lot of them joined together, it is polymer. Polymer. All right. Okay. So the type of polymer, the way we're going to join them together, is called an addition polymerisation. Really lovely word, addition polymerisation. I love long words. I don't know why. Maybe because it's a bit rhythmic. They're very rhyming. There's a rhyme to them. Addition polymerisation. What it means is you're sticking them together, right? And you're not losing any atoms at all. And I'm not really going to talk about losing any atoms. All I'm going to say is all you're doing is sticking them together, and it's the simplest form of polymerisation going. All right, cool. All right. We're going to talk about alkenes. We know alkenes. We did it before the half term, but just to really recap, alkenes have double bonds. Double bonds. The smallest of alkenes is ethene. I'm going to draw it for you. Okay. Oopsie daisy. So P now. And this is ethene. Carbon-carbon double bond. One of them. Ethene, MePb, is 2 carbons. This is ethene. This is, in addition polymerization, this is the simplest monomer. So in terms of the shape I drew, instead of having a hexagon, you have one of these. And I'll show you how it works. Each one of these is called a repeat unit. All right? Okay, now, synthetic polymers. Man-made. Synthetic means there's two. So there's synthetic or artificial polymers. I prefer the word synthetic. So you've got synthetic or natural. All right. So you have synthetic polymers, which are man-made, human-made polymers, and natural ones. So you've got some really cool natural ones. You've got cotton. You've got polymers inside you. DNA is a polymer. All right. Okay. Next keyword: covalent bond. We did covalent bonds many moons ago, but just to kind of recap it, it's a strong bond forming atoms share electrons. To share a pair of electrons is a single covalent bond. So it's the sharing of electrons. All right, catalyst speeds up a reaction, but does not get used up. That's a catalyst. So if this is ethene, and this is a monomer, let's write it on there. This is a monomer. This is ethene. If I take monomer, the monomer ethene, and I join them all together, so if I join lots of ethene, I make a polymer. And funnily enough, apart from the fact I can't spell join because I've hit the H, funny enough, if this is ethene and this is a monomer, and I want to change it to a polymer, I would call this polyethene. And we repeat it so often that you'll hear it all the time. It was like called polythene, not polyethene. But you can write either one. I prefer polyethene because you guys can then see where the name came from. We went from ethene, polyethene. All right. Another one that we use for pipes especially is PVC, polyvinyl chloride. That's an old name, and I'm going to show you it. Okay, now, the other term that you need to know is unsaturated, and I'm not sure if you remember. It really doesn't matter. I don't expect you to remember everything. When we looked at alkenes, so something I said was if something, when we looked at alkanes and alkenes, if something has a double bond, so I'm going to do propane, right? This doesn't have a double bond. This is unsaturated. Prop P is for 3 carbons, and again, I don't expect you to remember it. It's something that will happen with practice. Yeah. Full enough, it's like riding a bicycle. When you first start, you got to know where the brakes are. After a while, you just know where they are. You don't. No one has to tell you. So this is propane. There are no double bonds. This is saturated. Saturated. If I take the same molecule and put a double bond in, this is now propene. Right? This, you can add things to it, and this is called unsaturated. So the moment you have a double bond, it is unsaturated, meaning I can make it do stuff. It makes it more reactive. This is unsaturated. Unsaturated. Okay. Now, the next thing, how we write these. Now, I'm going to have a look at ethene and how it forms polyethene. And maybe you've done it in maths, maybe you haven't. This is ethene. I drawn it out, doesn't matter, job's done. Lovely. But we can have millions of these. And honestly, don't like writing big numbers. It takes too long. My hand gets tired. And sometimes it might not be a million, sometimes it might be 10,000. So what we do is use the term n. And this is what you might have done in number sequences in maths. You might have, you might not have, if you've ever done it. N means any number I pick. Right? It can be 1,000, it can be 10, it can be a million, whatever. So n means I am picking a number. I don't need to tell you a number. You can use any number you want. Right? And I can use any number I want. But what I'm going to do is I'm going to write n, so you know it can be any big number that I want it to be. And instead of having to join them all together and write, I've got one polyethene, you see the double bonds disappeared. It is added on to the next ethene molecule. I'm going to draw another ethene molecule here. And oh my God, I've got to go to a million. It's like, oh, it's going to take so long. Phew. But can't bother writing all this. So what we do is we draw the monomer without the double bond because it's connected to the next molecule, the next ethene molecule. We draw a bond out there, bond out there. We put these brackets, I prefer big square brackets, and we put N on the outside to say, look, I got loads of them. I can't bother drawing them. I've got better things to do. So this is the monomer ethene, and this is poly, many ethenes joined together. This is polyvinyl chloride, that's the old name. All it is ethene, but you've got a chlorine atom there. So it's not ethene, it's chloroethene. How many of them have you got? Lots. I could write a million there, but I don't want to because I'd have to end up drawing a million. So I'm just going to write N. Okay? And all you do is get rid of the double bond, drop a line either side. That means another polychloroethane molecule, chloroethane molecule is there. I put my square brackets around it and I drop an N. Some of this is going to sound really like, oh my God, that's so strange. Yes, it is. And I hope as you realize, the more we practice, the easier it becomes. Now you have got, 12 questions. So you got some easy ones. You got some, not so nice. And then you're, oh my God, these are mean. These are long answer questions. All right. So that's your work. I am going to stop recording. Oh, the one thing I will say while I stop recording. Oh, did I just? Oh, did I? Oh no. Come on, no. The recording's disappeared. No. Where's it gone? Why has it not stopped recording? Hold on, I think I've broken it.